welcome and hello everyone. Today, me and my groupmate are going to present to you our report for STA108 titled Correlation and Regression of Production of Logs in Malaysia. First, I'm going to introduce you to all my other group members. We have Nur Amira binti Zulkarnain, Raza binti Rahim, which is me, Syafiqah Azirah binti Rahman, Lee, Umi Fayura binti Muhammad Taufik. Without further ado, I'm going to pass the video to the first presenter.
Hi and Assalamualaikum, my name is Umi Karya. So today I would like to present the introduction of the report study. The background of this study report tells that Malaysia's land surface area used to be covered totally with the forest. Even today, forests still occupy around 54% of the entire land area today. However, it is because the country is still in a rapidly evolving process, so that deforestation become a main issue for the environment in our country. Malaysia's forested area decreased by 8.12 million hectares between 2011 and 2019. This correlates to a 28% decline in the covered area since year of 2000. Aside for deforestation, the remaining woods are endangered by sustainable logging, unauthorized removal of forest product, and encroachment caused by agricultural and urbanization activities. Next, logging or production of log is defined as the process of cutting down the forests for the purpose of selling them as a wood of pulp. The timber of tree is used to construct houses and furniture, whereas the pulp is used to manufacture the products like paper and goods from wood. Logging are divided into two types, which are selective and clear cutting of logging. So through this research study, an analysis was conducted on the production of log and the chosen forest area between the year of 1985 and 2014 in Malaysia. The purpose of this study is to investigate the relationship between the production of log and the forest area in Malaysia. This study also can determine the correlation and regression analysis between the production of logs and forest area in hectares. On this slide, it shows the objective of the study. Firstly, to investigate the existence of correlation between the production of logs and forest area using a scatter plot. Secondly, to analyze correlation between the production of logs and forest area. And lastly, to identify the simple linear regression of the relationship between the production of logs and the forest area. This slide tells us that every studies have their own significance on this investigation, which conveys us on further study about the forest areas that have been chosen to be cut down for the production of logs. Secondly, there are certain areas that may have a lot of trees that can produce a lot of logs, so the data in this analysis will indicate unevenly. The study also makes us become more aware of the environment and the fact that our forests are huge and have many possibilities to develop into many inventions. So as humans who live in this world, we should be more concerned about our diversity to ensure that it is in a good condition. Thus, this study shows the importance in giving our perception of the area of forest that is used to logging activities.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syafiqah Azirah binti Rahman, and I will be presenting the chapter 2, which is the methodology that we use in this study. So firstly, we will take a look at the data description. So this data is actually a secondary data that was obtained from the Department of Statistics Malaysia regarding forestry in Malaysia. So we already identified that the dependent variable Y is the production of logs, meanwhile for the independent variable X, it was the forest area, and both of these variables are actually a quantitative continuous variable. So that is for the data description. So after obtaining the data and identifying the dependent and independent variable, the method that we use is graphical technique. So this graphical technique helps us to visualize the data trend in a form of graph, and it helps us to save much more time in reading the data and bring out information from the data, especially quantitative continuous data. And graphical techniques is actually a very good technique to use to evaluate data before doing an exact statistical evaluation. So this graphical technique includes scatter plot and histogram. So scatter plot shows the relationship between the dependent variable Y with independent variable X. As shown in the slide, it shows the relationship between the forest area and production of logs. We actually can compare both of these variables side by side, and we can observe that if the forest area increases, then there are possibilities that the production of logs also increased. So the relationship between both of these variables that we could observe is actually a positive linear correlation. And secondly is histogram. Histogram shows that the x-axis are intervals of the dependent variable, meanwhile the x-axis show the number of times that the values occur within the intervals set by x-axis, which is actually the frequency. And from histogram, we could bring out information such as mode, median, and also the skewness of the data, in which if the data is skewed to the left or skewed to the right, or even if the data is symmetrical, we could observe it easily. So graphic technique also actually helps to bring out hidden information of the data that we couldn't see in the data table. So that is for the graphical technique. And for the last method that we use in this study is the numerical techniques. So numerical technique was often used for quantitative and continuous data for determining numerical measures by using formulas and calculations. So there are two types of numerical techniques, which is firstly correlation analysis and secondly is the regression analysis. So the correlation analysis measures the relationship strength and direction of associations between two continuous variables. For example, in this study, does the production of logs associate with the forest area, or even how does the forest area influence the production of logs? So there are two methods of doing correlation analysis, which is firstly by using the scatter plot and secondly by using the Pearson product moments correlation coefficient. So if we use the scatter plot, after we plot the data of the dependent and independent variables side by side, we could observe that if the plotting of the data shows the relationship between dependent and independent variables are negative perfect correlation or positive perfect correlation or negative linear correlation or positive linear correlation, or even if the datasets have no correlation at all, and lastly if the datasets have curvilinear correlation. And secondly, we could use the mathematical formula to calculate the correlation coefficient, which is known as the Pearson product moment correlation coefficient. So after calculating the R, which is the correlation coefficient, some of the examples is if the value of R is equal to 1, then the data has a positive perfect correlation relationship between X and Y. But if the R value is equal to 0, then the data has no correlation at all, which is the relationship between X and Y have no correlation at all. And lastly, if the R is equal to -1, then the relationship between X and Y of the data is negative perfect correlation. And the second one is the regression analysis. So regression analysis is a statistical methodology that utilizes the relation between continuous or numerical variables so that one variable can be predicted. It measures the linear association between continuous variables. So in doing regression analysis, the correlation coefficient must be measured to identify the significance between the two variables that is used in this study, so that the regression line could be determined to get the best fit line of the data. The reason of the existence of the regression line is to predict the dependent variables value based on the independent variables value, which can help modeling future data trend by using an existing data. So the equation for the simple linear model could be known as y equal to a plus bx. And to predict future model by using the regression line equation, the error terms and also the assumptions of the model must be considered in obtaining a good result. So that is all from me for the methodology in this study. Thank you.
Assalamualaikum and good day. My name is Nur Amira and my student ID is 2020476318. To continue our presentation today, I will explain about Chapter 3, Result and Interpretation.
Under Chapter 3, Result and Interpretation, first we have data presentation, second we have descriptive statistic analysis, which were divided into two parts, and lastly we have 3.3 correlation and regression analysis.
First, on 3.1, we have the data of forest area and production of log. There are a total of 30 secondary data that we took from the Principal Statistics of Forestry and Logging from the year 1947 to 2018 Malaysia. The secondary data was obtained from Malaysian Government e-Statistic website. From the data, the total of 30 years of forest area and
and production of log is calculated to be investigated between the two variables from the year 1985 to 2014. The highest production of log calculated are in 1995, which is 43,510, and the lowest were in 2013, which is 14,397. Next, on 3.2, we have 3.2.1, the scatter plot of production of log versus forest area. The dependent variable in the scatter plot is the production of log, and the independent variable is the forest area. With the dot to plot a mark in the graph, it represents a single data point. With a mark for every data point, a visual distribution and the relationship between the variable could be seen. Depending on how tightly the points cluster together, you may be able to witness a clear trend within the data. Next, on 3.2.2, we have a histogram of frequency versus production of log. The figure 2.2 show the production of log and the highest frequency between 20,000 to 23,000, which is 10, compared to 25,000 to 35,000, which is 1. Then we also have the descriptive statistic of forest area and production of log. The N value for forest area and production of log is 13, and the measure of central tendency, the measure of location, the measure of dispersion, and also the measure of skewness can be seen from the table provided. Lastly, continue to 3.3 correlation and regression analysis. First, we have a scatter plot of production of log versus forest area. The high forest area associated with high production of log. From the scatter plot, we can see that the pattern of the distribution in the statistical data was showing a positive correlation. From the data, it showed positive correlation, whereas when the forest area increased, the production of log also increased. An equation of y equal to 14,485.869 plus 0.662x. To conclude the output we have from SPSS, we are able to say that dependent variable is on axis y, which is forest area. In the correlation table, the R value is 0.149, the N value is 13, representing the data used in the analysis. The production of log associated with forest area has a strong positive linear relationship. In model summary, the R power of 2 is 0.022, so 2.2% of the variability in the production of log can be explained by the variability in forest area. The equation is y head equal to 14,485.869 plus 0.662x. Now the presentation will be continued by the next presenter. Thank you.
For conclusion, logging or deforestation is defined as the process of cutting down forests for the purpose of selling them as wood or pulp. The timber is used to construct houses and furniture, whereas the pulp is used to manufacture paper and good from wood. Logging may be divided into two types, which is selective and clear cutting. Based on the data that we have collected for this research, the results show a positive correlation between the relationship, forest area, and production of logs, which is the value of the correlation coefficient R is 0.149. As the area of the forest increases, reduction of logs also increases. If the situation still continues, we have a great consequences to our planet, such as loss of biodiversity, deforestation, the emission of greenhouse gases, and also climate change. the end of our report. Thanks for watching and have a great day.